You are about to do something no human being has ever done. You are about to step onto the surface of a moon so strange that scientists once wondered if it might be the closest thing to an alternate version of early Earth anywhere in the solar system. Its name is Titan, the largest moon of Saturn, and in a few moments you will feel what it is actually like to stand there. Your spacecraft has just completed a journey of more than 1,200,000,000 kilometers. As you descend through the haze, you notice something unexpected. There is no clear view of the surface. A thick orange atmosphere wraps around the entire moon, scattering sunlight into a soft, dim amber glow long before you ever see solid ground. Spacecraft measurements, including data gathered by the Cassini orbiter and the Huygens probe that landed here in 2005, confirm that Titan's atmosphere is almost 5 times denser at the surface than Earth's. You are not just landing on a moon. You are diving into a thick, hazy ocean of gas. When your boots finally touch the ground, the first thing you notice is how light you feel. Titan's gravity is only about 1/7 of Earth's, similar to walking on our own moon, but with one critical difference. Here, you have a thick atmosphere pressing down around you, which means a fall would not feel violent the way it would on the airless moon. Each step feels slow, almost like wading through water, because the dense air resists your movement, even as the weak gravity makes you feel like you could leap over a small building. You look up, expecting to see Saturn's rings or perhaps a clear starry sky. Instead, you see nothing but a dull orange ceiling of haze. Current evidence from Cassini's instruments suggests this haze is made of complex hydrocarbon particles, organic molecules formed when sunlight breaks apart methane, and nitrogen molecules high in the atmosphere. These particles drift downward over time, settling onto the surface as a fine, dark, sand-like material. Scientists describe this haze layer as one of the reasons Titan is considered the most chemically complex place in the solar system beyond Earth itself. As your eyes adjust, you begin to notice the ground beneath your feet. It is not rock in the way you might expect. Much of Titan's surface is covered in hydrocarbon sand, dunes built from solid organic compounds rather than silicate rock. Radar mapping from Cassini revealed enormous dune fields near Titan's equator, some stretching for hundreds of kilometers, shaped by winds moving through that thick atmosphere. You crouch down and run your gloved hand across the surface. It feels strange, almost like coarse coffee grounds, dry and grainy rather than soft. But the most fascinating thing about Titan is not what covers its surface. It is what flows across it. As you walk toward the horizon, you spot something gleaming faintly through the haze, a dark, smooth surface that almost looks like a lake on Earth. It is a lake, but unlike anything in your experience, because it is not made of water. Spacecraft observations confirm that Titan has rivers, lakes, and even seas made of liquid methane and ethane. This makes Titan the only place in the solar system, other than Earth, known to have stable liquid on its surface today. This raises an immediate question. Why is there liquid at all on a moon this far from the sun? The answer comes down to temperature. At the surface, Titan's temperature hovers around -179 degrees Celsius. At Earth's temperature, methane would be an invisible gas. But out here, it is cold enough that methane behaves the way water behaves on Earth, evaporating, forming clouds, falling as rain, and pooling into lakes and seas. Scientists call this a methane cycle, and it functions almost exactly like Earth's water cycle, just built from entirely different chemistry. You take a moment to absorb what this means. Somewhere above you, in that orange haze, methane clouds are likely drifting, occasionally releasing rain that falls in slow, gentle drops because of the moon's weak gravity and thick atmosphere. If you could safely remove your helmet, which you absolutely cannot, you would not smell anything, because your nose would freeze solid in seconds. Survival here without advanced protection would be measured in moments, not minutes. The combination of extreme cold and the complete absence of breathable oxygen makes Titan one of the most hostile environments humans have ever attempted to study up close. And yet, this hostility is exactly why scientists are so interested in this place. As you continue walking, mission scientists back on Earth remind you why Titan matters so much to astrobiology, the study of how life might begin elsewhere in the universe. Titan possesses many of the basic ingredients associated with the building blocks of life, including abundant organic molecules and liquid on its surface. Current scientific hypotheses suggest that the chemistry happening in Titan's lakes, while almost certainly too cold to support life as we know it, might offer clues about alternative biochemistries, possibly life forms that use liquid methane instead of liquid water as their solvent. This remains a hypothesis, not a confirmed discovery, but it is one of the reasons Titan continues to fascinate planetary scientists. But the surface is only part of the story. As your mission continues, instruments aboard your lander detect something happening far beneath your feet. Gravity measurements and magnetic field data collected by Cassini strongly suggest that Titan hides a vast layer of liquid water beneath its icy crust, an underground ocean possibly 100 kilometers deep. This subsurface ocean may be kept liquid by heat generated through tidal forces, the gravitational pull of Saturn stretching and flexing Titan as it orbits. If confirmed, this means Titan joins a small group of icy moons, including Europa and Enceladus, that may harbor hidden oceans, raising the possibility that liquid water, the most fundamental ingredient scientists associate with life, may exist far more commonly across our solar system than anyone once imagined. You glance back at your spacecraft, your only true shelter in this alien landscape. Communicating with Earth here is not instant. Signals traveling at the speed of light still take more than an hour to cross the distance between Titan and home. If something went wrong, there would be no real-time conversation, no immediate guidance, only the silence of deep space and the knowledge that help, if it came at all, would take significant time to arrive. This single fact transforms every decision an explorer makes here into something deliberate and unforgiving. Despite these extreme conditions, Titan remains one of the most realistic long-term targets for future human exploration in the outer solar system. Its thick atmosphere actually provides meaningful protection from cosmic radiation, something airless worlds like our moon cannot offer. Engineers and scientists have proposed that future explorers might one day use Titan's abundant methane as a chemical resource, possibly even as rocket fuel, since the raw ingredients exist naturally across its surface. This remains a future possibility rather than a current plan, but it illustrates why Titan continues to appear in serious conversations about humanity's long-term presence beyond Earth. As your time on the surface comes to an end, you take one last look across the dune fields and methane lakes stretching toward the hazy horizon. There are no mountains glowing in golden sunlight here, no blue sky, no familiar warmth. Instead, there is something quieter and in its own way more remarkable. An entire world operating on principles familiar from Earth, a working cycle of evaporation, clouds, and rainfall, but built from completely different chemistry, surviving in temperatures that would seem impossible to imagine from where humanity began. Titan reminds us that the universe does not need to look like home to be extraordinary. It does not need liquid water on its surface, or breathable air, or familiar warmth to demonstrate the same fundamental processes that shape our own planet. As you prepare to leave this distant moon behind, you carry with you a deeper understanding of how varied, how creative, and how resilient the physical laws of nature truly are, written here not in water and oxygen, but in methane, ice, and the quiet orange glow of a sky no human had ever stood beneath until now.